Today, as promised earlier, I will start with trigonometry. Trigonometry identities. Okay, I think you have solved the previous equation exercises and you have not faced any problem. I hope so. So now I have given 2 days time just because I wanted you to practice those exercises properly, because practice makes a man perfect. Okay, in maths you need lot of practice. Please practice properly. So next, as I told you, today we are doing trigonometric identities. What is an identity? First let me tell you what is an identity. Now it is an equation. It is an equation that is true no matter what values are chosen. Now what do you mean by this? For example, we have an equation x by 2 is equal to x into 0.5. Now this is an equation. For this particular equation, whatever value you take for x, you find that LHS will be equal to RHS. Suppose I take 100. So 100 by 2, it is 50. Now here also in the RHS, 100 into 0.5, it is again 50. So LHS is equal to RHS. So this particular equation stands true for no matter whatever values you take for the variable x. Okay, so this is said to be an identity. Now we are dealing with trigonometry identities. So what is a trigonometry identity? Trigonometry identity. So how do you define it? Again, it is an equation involving trigonometry ratios of an angle. Okay, so what do you mean by this? That means if you are dealing with trigonometry, that means you are dealing with angles. So whatever equation that you get in this trigonometry identities, you will find that for any value of theta, that stands true. The equation stands true. So today I will try to derive some of the equations, trigonometry equations. Now in standard 10, you have 3 trigonometric identities. You have 3 trigonometry identities which you have to solve. You have to remember. So try to remember. I will try to derive the identities today. So my method is, you first understand. Mathematics is not mugging up. Whatever identities you study today, if you do not understand from where you got it, then it will last for a very few days, 1 to 2, just like that. If you understand how you have got that identity, what was the procedure involved, why you did this thing, then I think it will be long lasting. So for trigonometry or any mathematical thing, you have to practice a lot. You have to understand. No need of mugging. Please don't mug up. Okay. So now what I have done over here, I have taken a right angle triangle which is right angled at B. Now this is right angle, so you know that AC is the hypotenuse, BC is the base and AB is the perpendicular. So let me apply the Pythagoras theorem over here. When I apply the Pythagoras theorem, then what do I get? AC square. What is AC square? Hypotenuse square. That is equal to AB square plus BC square. That means perpendicular square plus base square. I am naming this as equation number 1 because I'll be using this for 2 more identities. So it's better if I name it as equation number 1. Okay. Now what I do, dividing equation 1 by AC square, we get, now there is no particular rule. Why AC square? You must be thinking, why not BC square? Okay, we'll divide BC square, we'll see. But first, let me divide it with AC square first. Let me do. Then we'll find out if we divide by BC, what do we get? We divide by AB, then what do we get? Okay. So now I do it AC square by AC square LHS. Okay. So AB square by AC square plus BC square by AC square. Fine. Or let me arrange this one. Okay. I can write it like this. AB by AC whole square plus BC by AC whole square. Fine. Now this is 1. AC by AC is 1. Fine. Now what is AB by AC? What is AB by AC? I will take for this particular angle A. Okay. What is AB by AC? If AB is the base, if I am talking about A, then which perpendicular is facing this angle? This one. Which side? That means CB. So CB will be the perpendicular and AB will be the base. AB is the base and AC is the hypotenuse. So AB by AC, it will be cos theta or cos A. I am naming this as theta. Okay. Cos theta. This is a whole square. So if I put a whole square, it is same as cos square theta. Okay. And what is BC by AC? As you all know, I am talking about this angle theta. So BC is the perpendicular and this is the hypotenuse. So it is sine square theta. Now you got one identity. Is that clear? This is one identity. Let us name it as identity 1. Okay. Now we have got the identity 1. Now let me go to the second identity. Okay, I had told you that now you are dividing AC square. Let me see if we divide it by AB square, then what do we get? So to the same equation. Okay. So what I will do, I will divide equation 1 by AB square. Okay. If I divide by AB square, then what do I get? Fine. We get, so AC by AB whole square, I am directly writing. Okay. I am directly coming to this. And we have AB by AB whole square plus BC by AB whole square. Fine. Okay. What is now AC by AB? What is now AC by AB? If you can say AC by AB. What was AB by AC? It was cos theta. So AC by AB will be sec theta. So this is sec square theta. AB by AB, it is 1. What is BC by AB? What is BC? Perpendicular by base. What is it? It is tan square theta. Okay. So now you have got the second identity. Okay. This is your second identity. Now I go to the third identity. For getting the third identity, I go to the same equation. Let me write that equation once again so that it will be easier for us. AC square is equal to AB square plus BC square. Fine. Okay. Now what I do? Dividing the equation. I have named it as equation 1. Equation 1 by what you will divide now? What was left? BC square. See, here we have already done like first we have divided with AC and then we divided with AB. Now we will divide it by BC. If we divide it by BC, let me see. So what do we get? AC by BC whole square. I'm directly writing like this. AB by BC whole square plus BC by BC whole square. Fine. Okay. What is AC by BC? What is AC by BC? Now let me go to the triangle here. Okay. It is written AC by BC. What is AC by BC? Now BC by AC was sine theta. So AC by BC will be cosec theta. Okay. So it is square. I will write cosec square theta. What is AB by BC? Let me see. What is AB by BC? AB by BC. BC was the perpendicular and AB was the base. So perpendicular by base was tan theta. Now base by perpendicular is your cot theta. Very simple. So it is cot square theta. And what is BC by BC? It is 1. So now you have got the third identity. Okay. But I must tell you that all these three identities stand true for all values of theta ranging from 0 degree to 90 degree. Okay. 0 degree to 90 degree except the second one. Here second one you have secant tan. Okay. For 90 degree tan theta, do you get the value? What is tan theta for 90 degree? It is not defined. So for this particular equation, it stands true only when theta is between 90 degree and 0 degree. Not equal to 90 degree, but less than 90 degree. 0 to 90 degree. But for this one, again it will be 0 degree theta 90 degree. Okay. And for the third one also you have it is 0 degree to 90 degree. Okay. It stands true for all the values. Here one more. I think I have made a mistake over here. It is not theta greater than 0. Greater than 0. Because see cot theta. Here we have cot theta. Cot 0 is not defined. So I have to remove this equal to sign over here. So theta greater than 0, less than equal to 90 degree. Why? For this third identity we have cot theta and cot 0 is not defined. So you have to remove this one. Clear? These three identities you remember. So what was the first identity? Cos square theta plus sin square theta is equal to 1. Second, let me write down now. So the first identity was cos square theta plus sin square theta is equal to 1. What is your second identity? Tan square theta minus sec square theta is equal to 1. I'll write it in a ulta way. Minus tan square theta because sec square theta was here. So, or I will write it as sec square theta minus tan square theta is equal to 1. Okay. What is the third identity? Third one will be cosec square theta minus cot square theta is equal to 1. So these are the three identities you have to remember. Now in your book you have some examples. So let me do some examples over here. Okay, so that you will be able to understand. So in the example 12, example number 12, the question is cos A, tan A and sec A. You have to express it in terms of sin A. Okay, cos A, tan A and sec A should be expressed in terms of sin A. Let us try. Now from the first identity, what you have? Cos square theta plus sin square theta is equal to 1. So let us use that one. So from the first identity, cos square theta plus, now here it is A. So I am writing A now. I am not writing theta. Sin square A is equal to 1. Fine. So what is cos square A? It is 1 minus sin square A. What is cos A? Cos A is equal to root over of 1 minus sin square A. So now we have written cos A in terms of sin A. Okay. Second, what is tan A? Tan A in terms of sin A. Let us see. What is tan A? Tan A is equal to sin A by cos A. Okay. Is that clear? It is sin A by cos A. Now I am writing sin A. What is cos A? I have got it here. So it is 1 minus sin square A. Okay, clear? So now you have got tan A in terms of sin A. Now the third one is sec A. Let us see. What is sec A? It is 1 by cos A. Now what was cos A? We have already derived. So it is 1 by root over of 1 minus sin square A. So now you have got cos A, tan A, sec A in terms of sin A. Okay, now we go to the next example. So it is example number 13 in your book. So what was written over there? It was written sec A into 1 minus sin A sec A plus tan A is equal to 1. This was the equation. You have to prove LHS is equal to RHS. So let me take the LHS first. So in the LHS, first you have to write down. This is the way you have to write. Sec A 1 minus sin A sec A plus tan A. Fine? Okay. Now I will change this. See, sec and tan. I will write, see how I am changing it. Instead of telling so much, you see first. Okay. So what is sec A? It is 1 by cos A. Sin A I am not changing. I am keeping as it is. Again, what is sec A? It is 1 by cos A. And what is tan A? It is sin A by cos A. Now you understood what I wanted to say. Okay, I have changed it. I have kept sin A as it is. So now let me multiply. So here it will be 1 minus sin A, because this into 1 remains same, cos A, 1 by cos A plus sin A by cos A. Fine? Okay. Now I will complete this graph part. In this bracket part first. Okay. 1 minus sin A by cos A. So bracket part, it is cos A. Okay. 1 plus sin A. Now I'll multiply this. So I have 1 minus sin A, 1 plus sin A by cos square A. Okay. So this is in the form A plus B into A minus B. Then this can be written as 1 A square minus B square. So A is 1 minus sin square A by cos square A. What is 1 minus sin square A? 1 minus sin square A is cos square A by cos square A. So that is equal to 1. So proved. You'll write LHS is equal to RHS. Okay. So I have a very bad practice. See, I'm not writing equal to sign. So you please don't forget to put an equal to sign, and at the end you have to write LHS is equal to RHS. Fine. Now wasn't that easy? Okay. Now let me go to example 14 now. How to solve this example 14? Okay. So again you have to prove there is an equation, you have to prove it. So what is that equation? Cot A minus cos A by cot A plus cos A is equal to cosec A minus 1 by cosec A plus 1. Okay, fine. So here again I will first go to the LHS side. So let me write the LHS. I have what do you have in the LHS? You have cot A minus cos A by cot A plus cos A. Okay, fine. Now what is cot A? Cot A is reciprocal of tan. I am reminding you every time. So it is cos A by sin A. This is cot A minus cos A by, here instead of cot A I am writing cos A by sin A plus cos A. Fine. Is that clear? Okay. Now from here I am taking cos common. Okay. So I am taking cos A common. So what do we have? 1 by sin A minus 1. In the denominator also I am taking cos A common. So 1 by sin A plus 1. Cos A gets cancelled. So what do I have? 1 by sin A minus 1 by 1 by sin A plus 1. What is 1 by sin A? It is cosec A minus 1 and cosec A plus 1. So your LHS and RHS are same. Yes or no? So what do you write? Therefore LHS is equal to RHS. Proved. Clear? See. So what I had done here, after taking this, I have taken cos A common. So I have taken cos A common. Then now I'm left with 1 by sin A minus 1. Here also in the denominator 1 by sin A plus 1. Cos A gets cancelled. So I have 1 by sin A minus 1, 1 by sin A plus 1. What is 1 by sin A? It is cosec A minus 1, cosec A plus 1. So this is what you had to prove in the question. So now LHS is equal to RHS. Proved now. This is example 14 over. Now I will go to example 15, which is the last example. Then we'll go to exercise. Example 15. Fine. Okay. Now here it is little bit teda meda. Let us try. Sin theta minus cos theta plus 1 whole by sin theta plus cos theta minus 1 equal to 1 by sec theta minus tan theta, and you have to prove this LHS is equal to RHS by using an identity, sec square theta is equal to 1 plus tan square theta. You have to use this identity to prove LHS is equal to RHS. Okay, so once again let us start with LHS. Now I am writing it. Sin theta minus cos theta plus 1. See, I am writing the way you have to write it in your examination hall. Exactly. Don't miss any steps. When you are writing LHS, you have to write down the question first, It's not that for the examiner to understand, this is the question, this person is trying to refer, so he will go to that question. No, it is your duty to write it down so that the examiner sees the question from where you are getting the answer. Okay, so you have to repeat it. Don't be lazy, write down. Okay, so now you have sine theta minus cos theta plus 1 by sine theta plus cos theta minus 1. Okay, so what will I do now? I will do one thing. I'll change this. Let me do one thing. I will change this to the form of sec theta and tan theta. Okay, because here I don't find any sec theta and tan theta. So I find some relation of these two to this sec and tan. So let me convert this to sec and tan form. So for that, what will I do? I will divide the equation with cos theta. Okay, both the numerator and denominator. So now I have sine theta by cos theta minus cos theta by cos theta plus 1 by cos theta, and in the denominator sine theta, again the same thing, cos theta plus cos theta by cos theta minus 1 by cos theta. What is sine by cos? It is tan. Now you got it, cos theta by cos theta minus 1 by cos theta sec theta. Similarly, see, I have again forgotten. So here also tan theta plus 1 minus sec theta. Clear now? Okay, let me rearrange this. So what do we have? Tan theta plus sec theta. I am putting this in the bracket minus 1. Okay, for convenience you will understand why I have done this. And in the denominator also tan theta minus sec theta plus 1. Okay, now some manipulation. Let us do. What I will do, multiply tan theta, multiply tan theta minus sec theta to the numerator as well as the denominator. Okay, let us do, and let us find out what do we get. So if I multiply, then here let me see, what do I get over here? So tan theta into tan theta minus sec theta into tan theta plus sec theta. What will it be? It is a minus b into a plus b. So in the numerator you will have tan square theta minus sec square theta, because a plus b into a minus b is a square minus b square. Okay, minus, I cannot put 1, see, don't put 1, because tan theta minus sec theta is multiplied to this as well as this. So what do I get? I get tan theta minus 1 is there, so sec theta. I am keeping the bracket. Okay, so if I keep the bracket, there is no need of changing the sign over here. If I remove the bracket, then it will be plus, but I am keeping it as it is. And in the denominator it is the same thing, so I am not doing anything over there. I am not changing anything. I'll just write whatever it is written, whatever it was there earlier. Okay, so I am putting a bracket over here, and tan theta minus sec theta. Clear? Okay, now what is tan square theta minus sec square theta? See, here sec square theta is equal to 1 minus tan square theta, or tan square theta minus sec square theta will be equal to minus 1. Yes or no? So I am substituting here. Here it will be minus 1 minus of tan theta. I am putting it in bracket, or if I remove, chalo, let it be there, I have already put it, minus sec theta by, you have tan theta minus sec theta plus 1 whole bracket tan theta minus sec theta. Fine. Acha, now I am removing the bracket in the numerator. Minus 1 minus tan theta plus sec theta, and in the denominator I am having it like this, tan theta minus sec theta plus 1 tan theta minus sec theta. Fine. Okay. Now there is some trick over here. What trick? What is the trick over here? See, here I will do one thing. I will take, I'm doing it in a fresh page. Okay, so that it will be easier. I'm continuing it from here. Fine. So now you can see. So from here, what do we have? I'm taking, suppose, minus 1 common. What is common from here? If I take minus 1 common, then what do we get over here? It will be plus 1. Okay. Then from minus tan theta I have taken, so I will be having plus tan theta, and I have taken minus 1, so that will be minus sec theta. See, will this be fine or not? Whatever I have done, it is correct or not? From this particular equation I have taken minus 1 common. So if I take minus 1 common from here, so what do you have? Plus 1, because minus 1 plus 1 is minus 1. Then minus 1 into tan theta is minus tan theta. Minus 1 into sec theta is plus sec theta. So I can write it like this. Fine. And in the denominator, let me keep it like this. Tan theta minus sec theta plus 1 tan theta minus sec theta. Now what do you find in these two equations? Can I cancel? See, plus 1 tan theta minus sec theta. So these two can be cancelled. Now what do I have? I have minus 1 by tan theta minus sec theta. Okay? Or I can write it as 1 by sec theta minus tan theta. Clear? Can I write? Okay. So what was the proof? See, it was written sine theta. See the paper over here. I have to prove this is equal to 1 by sec theta minus tan theta. Done. Okay. So what will I write over here? So LHS is equal to RHS. Proved. Okay. So this is all about the examples. You please try exercise 8.4. I will definitely give you the solution in the next video. But you please try. If you are not able to do, then you can refer my video. And if you have any problem anywhere, please write to me in the comment box. Clear? Thank you. Bye. And take care.